So we're ready.
Yep, good to
Thank
go.
you,
So,
George.
yep, go for it, Steve.
Thank you, George. Thank you very much. And thank you, audience, for attending today. We're actually holding our end of the webinar in the United States. We're headquartered in San Diego, California, and you'll have some guest speakers that will be one from Phoenix, Arizona, and one from Richmond, Kentucky. So appreciate the time and the effort. Today, we're going to talk about Aramid fiber, specifically the Aramid fiber that Surface-Tech manufactures and supplies. And we're very pleased to have the team of Enforce Global at your disposal with regard to our distributor in New Zealand and Australia. They've done a very good job of vetting the product over the course of the last couple of years and have really taken a shine to the technology from all of our stewardship that we can provide them, both in terms of long distance, but also in person. So I think you're in very, very good hands with regard to the team of Tom McGaviston, George Field, and Crawford Fisher. They are very, very in tune with regard to our product and our technology. Today, I have with us, my name is Steve Santa Cruz. I'm the president of Surface-Tech, again in San Diego. Surface-Tech has been a company in the space since 2013, and from that period to now, we have done a very, very solid job of respecting the science and really testing the product, both in lab and in field, throughout all of North America. We also have a lot of international interest beyond Australia and New Zealand. So it is a very international oriented product that has a lot of promise with regard to what it does in asphalt in terms of adding life by reducing cracking and also helping with regard to the rutting aspect. We also have our COO, Pat Weaver. Pat brings 38 years of plant expertise, a renowned expert in his field, both on the ready-mix side and the asphalt side, has worked for some very, very large organizations called CRH, which is a huge global conglomerate, as well as Vulcan Materials, which is a very, very large national, actually multinational in North America. You'll get a very, very sharp perspective with regard to his knowledge on the plant side, but how the product actually works in that environment. We also have our CMO, Jason Martin. Jason comes to us from a host of different design and marketing backgrounds, most notably with Nike. He was one of their founding original members, let's put it that way, with regard to their team on the design side. He has some very, very keen, notable aspects with regard to that group, but he has gone off on his own and has done several different entrepreneurial endeavors, and we are very fortunate to have Jason on our marketing aspect. I think you'll see the Surface-Tech messaging that you see on social and on our website very much a product of Jason's creativity. We also have on the call today Phil Blankenship. Phil Blankenship is a world-known asphalt specialist. He is an R&D I call him a steward. We call him an asphaltist, actually, and he has a background starting at the Koch Industries and then has worked at the Asphalt Institute in the United States, two very, very big, well-respected organizations in asphalt, and has broke off on his own. And we are fortunate to have Phil as our R&D partner, but also as a third-party PE and influencer with regard to our product. He is very knowledgeable with regard to Aramid in space. He has tested in all aspects of that product. Go ahead. Go forward, George. Next slide. You know, we do believe in better. I'm going to try to keep this going fast because we would like to get this done in about 40 minutes and then have plenty of time for Q&A. So I've indicated that we are very proud of having Inforce as a partner, but we're also something that you guys need to understand. We're a very, very low carbon pavement solution ingredient, something that is very much a part of our diet these days with regard to legislation that has passed in the United States to really bolster the transportation industry to the tune of about $1.2 trillion that will be deployed over the course of the next 10 years plus. And we are in a very interesting transition with regard to a low bid to low carbon environment in the United States. It will take a little time for that to happen, but nonetheless, we are very, very much that type of a solution with regard to the industry. Next slide, please. We enhance traditional pavements, and we do that by providing a mechanical connection between aggregate and asphalt binder. And we provide a fibrous tensile solid in a 3D aspect, or we're temperature tolerant. And we have a more stable mix that really marries up to the aggregate very well, our fiber does. And that does then enhance and supports the bitumen aspect. And at this stage of the game, I am going to turn that over to Mr. Pat Weaver, and he's going to take these slides for a while. Pat?
Good morning. Good afternoon in the US. I guess it's tomorrow where you all are at, which is kind of a cool thing. And every time we speak to folks in New Zealand and Australia, it's like looking forward in time, which is pretty cool. So we're going to talk about, obviously we're on a call to learn more about ACE XP Aramid fiber solutions, but we're going to start off by looking at what typical pavements look like as they age and as they get beat up over time. This is a slide of some typical pavement distresses, fatigue distress, bottom up cracking, thermal block cracking, reflective cracking from overlays, thermal cracking, and many times there's a combination of all these pavement distresses that we have that we're dealing with as asphalt pavements or bituminous pavements age over time. And we're going to talk about how our product helps with each and every one of these in just a few minutes. Next slide, George. Here's a couple other, forms of pavement distress, surface raveling, which can lead all the way down to full destruction of the pavement, rutting issues for a variety of reasons, whether it's binder related, whether it's, mixed design related, a combination of both. And then, many times moisture damage goes hand in hand with raveling. We run into that a lot. I'm in the Phoenix, Arizona area, and those things tend to go hand in hand here in Arizona, where, once in a while it does rain and it does a tremendous amount of damage to the surface, which results in raveling and so on. And so these are a lot of the different typical pavement distresses, and I trust they're similar to what you all experience, in Australia and New Zealand. Next slide, George. Okay, so yeah, we all experience all over the country. This is what happens with asphalt. Asphalt ages, asphalt breaks apart, and asphalt falls apart. However, it doesn't have to as readily or as quickly deteriorate as we've seen it in most of our lives. And what can we do to help with that? Well, first of all, we're going to talk a little bit about what makes up our product, and that's Aramid. So what is Aramid? Aramid fibers, that's short for aromatic polyamide fibers. It's a high class, or it's actually a class of high performance synthetic fibers known for amazing strength, exceptional heat resistance, the lightweight properties, and many other aspects. So Aramid itself has a melting point over 425 degrees C. It's 5 times the strength of steel, which is quite amazing when we show you some pictures in a few slides of what our fiber looks like when you pull it all apart and look at the individual strands. And each strand has a 400,000 psi tensile strength. Quite amazing product, high modulus. And here's the big thing with our fiber, with Aramid fiber, that's so different than other fibers. Most other materials you put in the asphalt in a fiber form will absorb asphalt cement. In fact, that's what, like cellulose fiber is made for, mineral fiber is made for. Aramid fiber is not made for that. It does not absorb asphalt cement. It likes asphalt cement. We're going to show you a couple slides in a minute that'll show you that. But it loves the connection, but it does not absorb. So it doesn't change mix design. You don't have to add oil to the mix. There's no change in volumetrics and VMA and air voids, and you don't lose effective binder content. And the other good thing about Aramid is it's non-toxic. You look at it and you say, oh, can I touch that without wearing gloves? Yeah, actually you can. In fact, I'll show you in the next slide why you can. George? So Aramid in use. 1971, DuPont commercially started producing the first generation of Aramid fibers under the brand name Kevlar. Kevlar is a pyramid fiber. I mean, the molecules are highly oriented along the fiber axis, which gives it outstanding strength and rigidity. We all know, have heard of Kevlar and what it's used for: body armor, aerospace components, ropes, protective gear. Obviously, that's what I mean. There's no issues with touching this fiber because we make clothing out of it. We make protective clothing out of it. We also make the what used to be steel belted radial tires, or the material inside aerospace, airplane tires. It's all done with Aramid fiber now. It's pretty amazing. Another application is a product called Nomex. It's a meta-aramid fiber, slightly different, excellent flame and heat resistance. So a lot of insulated gloves that you might wear for welding or handling super hot materials, and also are made from Nomex, as well as the baghouse bags and every asphalt plant that uses baghouses on the planet, made from Nomex, which is it's a meta-aramid. A little bit slightly different, but still an aramid fiber. And lastly, we continue to find different fantastic uses for aramid fiber, and we think we've found one of the best in our ACE XP. So how does it work? How does aramid fibers themselves work in asphalt? Well, the aramid fiber creates a three-dimensional reinforced composite material. We call that composite material ARCA, and I'll talk about that in just a minute. ARCA stands for Aramid Reinforced Composite Asphalt. When you take the loose fiber and it gets mixed into the mix under a magnifying glass or a microscope, you can see what it looks like. Very much you can see the hair-like fibers with the little barbs on it. Well, those barbs love asphalt, and it allows it to root into the binder. Those fibers also love the surface of the aggregates. It bonds to the granules of the aggregate as well as the surface of the aggregate, and that's very, very important in the functionality of how this comes together. So combined, rock and sand or aggregate, bitumen, and aramid fibers creates what we call ARCA. George, do we want to pause here for a second for any questions? I see a couple on the Q&A or chat.
Yep, good. That's good. Pat, we've got a good question here. It's to do with wrap. So the question was asked, using product upper layers, which may be recycled for wrap. Does this put the wrap into the contaminated wrap category and hence unsuitable for reuse?
That's a really, really good question. because many times when when you use like a fabric material, and you mill that up into the wrap, it makes it very problematic to use. Our product doesn't. Our product loves to be reused over and over. It's such a fine product that as it goes through the milling cycle and the crushing cycle, you actually gain benefit in the wrap. So it does not ruin the wrap whatsoever. But that's a fantastic question.
Yeah, cool. I think that Pat, and there's another good. There's a couple more here. I might as well go through them now while they're there. So that, can we explain the ACE fibres versus fiberglass reinforcement?
I can do the best that I can. So a fiberglass reinforcement, obviously we know fiberglass is a significantly different product. Glass does not like liquid asphalt binder. It pretty much it repels that. And the ACE fiber being a aramid fiber is really connects well with the binder, which is the most important thing. You want the binder to connect to the fiber and you want the fiber to connect to the aggregate. And fiberglass does not do that. Fiberglass is great for lots of other applications, but not in this regard. Hopefully that's helpful.
Yeah, that's good. Thanks. Thanks, Pat. There's another one there too about the product. Do we produce it in different lengths or diameter ratios?
So we don't change the diameter ratio. The fiber comes in a specific fabric size that we utilize, but we do have different lengths: 38 millimeter and 19 millimeter.
Good. And I think just to clarify, for the Australasian market at this point in time, we're just sticking with the longer fiber, which, from what I understand, gives a slightly better performance. Is that correct?
That is correct.
Very good. We've had a couple of questions from Brian as well about the some various case studies have they been carried out, which we'll come to later. So we'll hopefully answer those questions down the track, Brian. But keep them coming. It's good.
Next slide. So here's where the aramid meets the road, if you will. How does the aramid impact the asphalt mix? Number one, it extends pavement life. Well, that's an easy thing to say. That sounds like a sales pitch. Actually, it's not a sales pitch. It's the reality. We improve crack resistance in a tremendous way. When you mitigate crack resistance, and then the fiber also slows down the crack propagation when cracking starts to occur. When you do that, that is one of the biggest aspects of proliferating the life of an asphalt pavement material. We also improve the rut resistance. Now, here's the big deal with that. Typically speaking, when you improve crack resistance, you reduce rut resistance, and vice versa. When you improve rut resistance, you hurt your crack resistance. Well, our product does both. It helps crack resistance in a major factor, in a really big way. And just to the right, we're not going to camp on those test results, but this is just one project that we did where we put a wheel tracker on two different mixes on the same project. And when you introduce the fiber in single doses and in double doses, depending on what we are looking to accomplish with equivalent single axle loads, sometimes we'll use more than a single dose. We'll double dose it, or use a 1 1/4 dose, or 1 1/2 dose. There's a lot of different reasons I'm not going to camp on right now, but you can see we reduced the rutting over 20,000 passes significantly with different types of bitumen, and that's what this shows us. The ideal CT, that's one of the crack tests that we have in the U.S. Being 50 states, we have 50 different ideas on how to measure crack resistance. Really not 50, but probably a half dozen. But this just shows graphically, from a control mix, the number of 65 goes up to 94 with a single dose, and a double dose of 130 with one type of binder. And you can see the impact with another type of binder to your right. That's what aramid does. When it gets into the mix properly and it's well mixed and it creates that three-dimensional array within that aggregate and binder structure, that's the type. So if you look at it proportionally, you can see up to a 4 times improvement in crack resistance from this one project, this one lab test, and up to a 3 times reduction in rutting with that same mixed design when it comes to a wheel rut test. So those are some very unique results, amazing results from a laboratory perspective. We're going to show you some stuff in a few minutes with some case studies that in the field, the numbers are even more extraordinary. So depending on where you're at, you know, and depending on your aggregate quality, obviously you got to have good aggregate quality to start, good binder quality to start. When you do all those things and you put aramid fiber with it, it extends the life of the pavement, you know, anywhere from, I would just say 50% to the sky's the limit. And we'll talk through more of that as we go. Next slide. Steve's going to take over from here for a little bit and tell you about ARCA.
I've just got a couple more questions here. Do you want to jump into them now, Pat, or should we?
What are they referring to?
So the first one was, can we explain the ACE fiber versus other products in the market? I'm picking that's other fiber types.
So again, the typical fibers in the market are cellulose fiber for hot mix asphalt, would be cellulose fiber, mineral fiber, aramid fiber. And effectively, the fiber products that are out there that are either mineral or cellulose, they're basically a function of utilizing in like a stone mastic asphalt type of mixture that would help bulk up the binder to reduce drain down during production, during manufacturing, and during transportation. They do not add structural value whatsoever into the mix, where aramid fiber is a structural enhancement. It's made specifically to add structural value to the pavement. Does not, it helps with drain down, but it's not made specifically for those applications like cellulose would be. You know, cellulose sucks up oil, if you will, and acts as like a filler. Our product's not a filler. Our product is a structural component. That's the biggest comparison with products in our market.
Great. Yeah, thanks. We've got another good one here regarding the binder PG70-22M assumes is a PMB SBS, and can you please explain the single and double dose?
So say the first part one more time for me between the
I'll just jump back to the slide. So the PG70-22M we assume this is a PMB, polymer modified binder with maybe an SBS. Another question?
Correct.
Can you explain the single and double dose?
Absolutely. So let's start off with typical. Obviously, is the control has no fiber in it whatsoever. A single dose of our fiber is 2.1 ounces or 65 grams per metric ton. That's a single dose of our product. A double dose is twice that amount. So this was where we were doing a study to see the impact of increasing the dosage rate of the fiber. And it's quite an amazing product. You can keep going. You can triple dose, quadruple dose. It's just the bang for the buck you get. You start hitting losing the return on investment. It gets really expensive at the super high rates, but you can't overdose it. That's kind of the explanation. Now the 64-22, that's a typical non-modified bitumen in the US. And so the rut resistance on this project with this mix design, and again, I'm not certain what the aggregate nature was, whether it was crushed gravel or if it was crushed granite, not sure. But you can see the double dose really in the neat binder helped tremendously. I mean, it just went from 12.5 millimeters all the way to 4.2. That's a big improvement on rut resistance. 12.5 again on a 70-22. So you can see where the the polymer modified binder didn't have an impact on the rut resistance by itself. When you add a single dose of fiber to that, you can see it drops into the same range as a double dose would do in a non-modified binder. And then you go to the double dose, doesn't have a big impact on the modified binder. Now, conversely, on the crack resistance, it goes through the roof. You see just a single dose and a neat binder here is a 50% improvement in crack resistance right off the bat. And a double dose is a 2 times, a 2x value. And then you add the polymer modified, again, you get the big bump with the single dose and then a really large bump with a double dose. We're going to go in about 20 slides from now, we're going to talk about that more. How eventually the polymer modification wears off over time, but the fiber doesn't. Pretty neat results coming up in one of our case studies we'll share in a few minutes.
Great. I'll keep going with these questions if you're all right, Pat. I think they're pertinent. And then we can, there was one question here about interlayer technology, which we're going to come to in a later slide, Peter, so just hold off on that one. There's just a question here. Have you looked if there's a possibility of microfibers similar to microplastic contamination from surface wear, possibly being washed in water streams? So I think this is sort of like a runoff scenario.
And this is a very, very important question because human health is super important to us. I've been in the industry for almost 38 years. I know from my picture, it doesn't look like I've been in more than 10. That's a joke. I've been doing this for a long time, and we've been worrying about contaminants and things that run off. And in the lab, but prior to my coming on board with Surface-Tech, I played with plastics in asphalt mixtures, recycled plastics to try to utilize that product. And one of the things that I learned was the microplastics is a reality and it can be problematic. So that's when I stopped my research into that and went to work for Surface-Tech with the Aramid Fibre. The Aramid Fibre does not have an issue with water runoff. There's no issue with Aramid whatsoever in that regard. So it also holds on to the aggregates in the binder so much more readily than even the fine aggregate gradations that might come off during the aging and wearing time, of a pavement's life. But one of the things that I really like about our fiber product is the fact that it's not it doesn't disintegrate and become a hazardous chemical whatsoever. It's very much a sustainable, environmentally friendly product.
Great, thanks, Pat. So just a couple more questions here, Ryan. So NCAT field trial results, we've got a slide on that down the track, so we've that's definitely in play. What is the end of life failure mode with Aramid and mix?
The end of life value, is that what you said?
The end of life failure mode.
Well, basically, the end of life failure will be with everything but the Aramid fiber. As the binder ages and the aggregates have problems with long-term, freeze thaw cycles or problem with grinding of the vehicle, in that type of wear, you're going to find that the mix matrix falls apart before the Aramid fiber falls apart. In fact, the Aramid fiber is what's holding it together longer. If that answers the question.
Yeah, I think that does. Thanks, Pat.
Think of it this way: when you see a concrete structure that is being, taken down and broken apart, one of the toughest components of recycling that concrete structure is the rebar that's in it and dealing with that. That'll be the same way with our fiber and asphalt. It holds everything together super, super well, but it's not as problematic as rebar and the recycling issue. I'm just trying to give you a little different picture.
Good. Thanks, Pat. To be clear,
Aramid does not rust.
Aramid does not rust. Yeah, there you go.
Very good. So
George, let me.
Yep. Go, Steve.
I think I have, let me put a handle on a couple of these very quickly and I'll jump into the slides so we can keep this moving, but I really appreciate the Q&A. And first I want to shout out to Peter Levitt. Good to see you, Peter, on the call. Long time haven't talked to you. It's really good to hear that your interest is still very much there with regard to the product line. And Ryan Jantz has asked something along the lines of dosing questions and why only 2 doses. And you know, what we can share with you is that the dosing benefit with regard to what we have found in the lab in the field is a linear benefit. Make no mistake about that. So as you add dosage to the mix, it only adds to performance. What is the restriction is economics. So if you are marrying, if you really want to get up into a very full depth, concrete-like structure, you can add more dosage. And at that point, economics is probably still a concern, but not as much. So there you can design appropriately with regard to it. But the 2-dose situation tends to be in the world of what we deal with on most applications, a fair and acceptable economics. And George can get into that with you afterwards with regard to it. With regard to moving on to try to keep pace with regard to the webinar today, as you see, that's what the picture in the slide here is worth 1,000 words. That's the fiber holding on to the aggregate and creating a 3D structure within the mix. And as it goes in and it's compacted, you don't see the fiber, but this picture is a really good depiction of what's going on in there as it is getting compacted or prior to getting compacted. So it does really create that 3D mix. There's probably 8 slides that are going to go on here that gives you a little bit of detail on characteristics of the product and whatnot, but I'm going to save that. You'll get access to this afterwards. But I do want to mention that the products are EPD certified. These are a couple of the very first construction material products that gained EPD certifications in the world. It is also a product that now has a ASTM standard so that it makes for specification cleanup very nicely in the sense of eliminating a lot of legacy and interpretation issues with regard to the product. So you now have a global standard that really helps with regard to legitimizing the product, especially as it relates to specification work. It is a dry material. It is a low dose material, as you heard, 65 grams per metric ton. So there needs to be care with regard to how it's inserted in the plant. That is another very important aspect of this particular product. And we have engineered our own equipment. And in fact, an example of that equipment is in space with Inforce, and they are getting more equipment. It is a metered piece of equipment that is very easily managed at the plant. It is a machine that matches speeds with regard to the plant, provides daily reports, can have a PE stamp to certify the mix if necessary. If you have an agency that's requiring that, you can do that. And that is a big differentiator with regard to the other product that is in the market, that is Aramid, where that particular product is just blown in without any metrics or any type of validation. This is something that we have really done a lot of work on, and very proud of that equipment that makes the plants comfortable, confident, and can rely on the equipment to get in the manner that it's supposed to be. And that is really an important aspect of all of this, because if plants aren't comfortable with regard to what's going into their mix and can validate what's going into their mix, things don't go into their mix. And we've done a good job with regard to getting that confidence Yeah, very much an everyday thing now. I see Peter asked a question about polymer binder reduced performance over time. The thing I can share with you is that we have an ability to marry up to a neat binder with our product, and it can provide for PMA performance metrics. And that's a very big thing for those of you who are familiar with PMA, because it answers the question of availability, storage, ease of use at the plant, and most importantly, the carbon push-off that you get with regard to using their product or that product versus Aramid, which is a very low carbon introduced product. Let's see, any of these, what is the end of life failure? I think we answered that question. Daniel has a question. Pearson's product's the biggest bang for the buck at the extreme operating conditions where abnormal performance is needed and traditional methods do not perform adequately. Is this a fair assessment? I think you can. I think definitely you can say that under the extreme conditions it does do well, but I think you're missing out on the fact that your regular overlays, your everyday stuff that dominates the work that's done in the field right now is something that this is an easy add to. Does not change volumetrics. You don't have to change mix design. It's a complete add to it. It will not impact anything with regard to the existing JMF, other than once it's in field, it's going to perform much better. So yes to the extremes, but also to the norms. In fact, it's your workhorse product. All right, so I think that took us to probably, and then I want to make sure that you guys understand in our messaging that ARCA, it is Aramid Reinforced Composite Asphalt, and we have used that acronym in place of the old one called FRAC, F-R-A-C, Fibre Reinforced Asphalt Cement. It's a much more engineering term than that old one. So when you hear ARCA, that's really what it is. It's a category kind of reference, and we have kind of attached ourselves to ARCA. I think at this stage of the game, we can go right into some of the case study look-sees, and I think that will keep us right on time here. Is that okay, Pat? You want to take it back over?
Sure. And basically what we're saying is, ARCA really does stand for long, it does create. When you use ARCA instead of a standard hot mix asphalt, you get longer life pavements. And it all starts with ACE XP. That's this product right here. That's what we've been talking about. If you look at it, it is more than just a chemical modifier. We've already talked about how our product physically reinforces the pavement. We've talked about that a lot. It is the only performance mix modifier with published EPDs, and it's basically, in order to do the EPDs, we in the US utilize National Asphalt Pavement Association, EPD tool, and it's the only one of its kind that's already pre-built into the tool. So that's a picture of what the so the product looks like these sticks. We can see it's made up. Each one of these sticks is about 10,000 fibers. Go ahead, next slide, George. So what is ACE XP? It's a blend of Aramid fiber plus Sasabit wax. The Sasabit wax holds the strands together in these little packets. That allows for the Aramid fiber, which is extremely light, to not blow away in the wind or get sucked away in the plant air quality system. So again, like I said, 10 to 12,000 fibers per bundle. The wax melts at a very low temperature, which allows, once it's in and we're going to talk through this a lot in a few slides, but once it gets into the hot plant through the wrap collar, it goes from this fiber bundle into the individual strands. We've said this a lot. The wax is so minuscule, it does not do anything. Basically it's 0.0001% addition to the liquid binder. And if anything, it would help, but it does actually, it's so small of amount, it does nothing. So because the mix designs don't change, the placement practices don't change, there's nothing you have to do to your mix designs. So that's what we're bringing all together. That's what ACE XP is. Next slide. So again, this kind of summarizes the form factor, which is very, very important. Some of the questions already asked, but no worries with stormwater runoff, no plastics. There's no plastic that are part of our componentry. There's no other fillers. We don't have to worry about that. Because there's no plastics, there's no other material that's problematic. There's no other fillers. There's no risk of additional VOCs that would impact stack testing. So when you run the product with your asphalt mixes with and without fiber, the VOC content does not change because there's nothing that burns off.
So Pat,
Yes, sir.
Pat, I think it'd be a good idea, because I'm trying to keep, an eye on time. If we introduce Phil, let Phil he's typing an answer right now, take that question and the other three underneath it, and then let him talk about the lab mixing. And then we'll end with regard to some of these case study pictures that you got.
Fine.
I think that'd probably be the best way to go. So Phil, can you chime in here and let's answer these questions? You've got one that you're writing right now. Let's start with that.
Okay. Yep. Thank you all, and glad to join you from Kentucky. So one of the questions was, will it fix a stripping problem? Well, stripping, of course, is all due to the adhesion of the asphalt liquid or the bitumen to the aggregate. So it will not fix that problem, but it does help through the promotion of cohesion, and that is holding the mixture together. So if you were to look at it, what they would call a Catabro or Cantabro test, where you're putting the mixture in and tossing it around with the other samples and looking at how it will hold together, yes, it will help. Yes, it helps in a Hamburg device. And of course, that's another way to look at the stripping. And then again, on the TSR, it just depends on the mixture. So so no, in a traditional sense, yes, it will help hold the mixture together. Is there a pavement design process in any jurisdiction in the U.S. that allows a design light offset? There's nothing that's, I guess I would say, documented and in place other than what I would add to that is there's a lot of discussion right now at the National Academy of Science Transportation Research Board. So I sit on the committees with the other folks, and the discussion right now that's around that is understanding the parameters we can put in. So yes, we can put something in to offset on thickness, but that's really not the goal. The goal is to add life to pavements right now, and what it's not fair to do is just try to help and understand that it improves the structure. When it improves rutting, it improves cracking, it improves fatigue life, it improves the overall structure. So there's Aramid fiber is ahead of its time, so people are trying to catch up with it. Is there a documented procedure? No. Is there a lot of current knowledge out there on how to use it? Yes. And I've got designs I've actually done on that myself, and then there's other designers that have done the same. Which mixes and thicknesses of the layer is suitable for Aramid? Can it be used in SMA, OGFC, DGA? Yes, and yes. And where it can be used, and I'll probably give you an example of how I've used it that may help. First off, the last one is, are there any minimum layer thicknesses? No, absolutely not. In using it in an open graded type of mixture, you're not trying to prevent cracking, you're trying to hold a mix together. So again, in helping mixture cohesion, absolutely it will. And looking at SMAs, because of the higher asphalt content and the typical polymer that's located with it, It's going to make that mixture even perform better. There's quite a bit of work that's been done in Colorado, where the lab tests have been astronomically impressive when you're looking at crack resistance. Does it absorb the asphalt like the cellulose, and can you substitute the cellulose for cellulose fiber? No, you cannot. It will not absorb. So you still use your cellulose fiber or some type of mineral filler to help with the drain down. And as far as which layers to use it in, I've used it in I had a project where I had to go up against concrete, and I was looking at about 25 millimeters of concrete that we were going to, I see 25 millimeters. We were looking at about 10 inches. So about 250 millimeters of concrete that we're trying to replace, or 2.5 centimeters, 25 centimeters. I'll get my numbers right here in a minute. I'm trying to convert over from 10 inches. So 250 millimeters. And when we went head to head with that, we had to come back with a similar thickness. So what we did was instead of putting down more asphalt, we actually were able to use the existing asphalt design and replace the structure with an aramid fiber reinforced base. When it got to the top 25 millimeters of surface, that was important to understand that there it wasn't as much structure, as we were trying to have a very durable surface, and especially the top 50 millimeters is to have something very durable and shear resistant underneath the wheel loading. This was at an intersections that were concrete that were being replaced going into the local airport here in Kentucky. Let's see. Oh, okay. How do road agencies specified aramid fiber in the U.S.? And I want to jump down to that one. We're simply, the easiest thing to do is call out ASTM 8395. Some of them have had old legacy specifications, but at the end of the day, they're calling out those values that you'll see in the ASTM, which are tensile strength, modulus, break strength. Those things begin to classify this fiber. This fiber is not just any old fiber, so it's very important to call out that type of aramid, para-aramid that's used, that's Pat mentioned. With that, it's simply called out and it's specified on a grams per ton basis, or in the US, of course, we use ounces per ton. Do we need to make allowances in binder recovery for quantity assurance in case the binder washes off completely? No. Matter of fact, I've actually recovered the binder in my laboratory using an extraction. I've even used an auto extraction device. When we use chemical extraction, that's not a problem. If you use a burn-off oven, that's not a problem either, as the fiber is so lightweight. If you're using chemical extraction, it will either catch on a sieve and an automatic device, or if you're in the other devices, it would catch on your filter paper. And you can actually see that fiber into your mixture, and it will usually begin to together. You can run it over a nest of sieves and of course begin to wash it out. Let's see. Do you think ACE XP can replace or partially replace SBS? I do. I like to use it with SBS, and you get sort of a 2-for-1, but can it replace it? Yes, in the sense that it's expanding your grade. Is it going to lower your binder grade? It will not soften the binder, but it will do the equivalent of helping on the lower end crack performance. There was another question earlier that was really good on, that goes along with this about can we actually use it with wrap? Yes, we can, and I've used it up to a 45% wrap project in Kentucky. And matter of fact, the city is now using this high wrap mix design on 20% of their city mixes. That's done with a contractor who has great knowledge of how to handle wrap in a quality way, how to stockpile the wrap properly, how to properly grade it with a double screening deck, not running too fast to make sure it's dried out. And in that case, we actually used a combination with a bio oil to soften the binder. But then if you do that, you're at risk of rutting, you're at risk of other cohesion and other things that you can deal with wrap. when you put the ACE fiber in, you offset all of that risk. And again, it just makes it better. Does the volume of fiber in the asphalt cause any issues with workability? Absolutely not. Matter of fact, we hear just the opposite, that when you put the fiber in the mixture through the 3D reinforcement, if anything, it helps to hold the mat together laterally. That's Phil's opinion on how it works. And by holding the mat together more laterally, it should be able to help you gain density. I have no proof on that other than what contractors have told us. I've answered quite a few of those. I probably missed some as they were jumping around in there.
There's one there about sorry, Phil, there's one there just about the being able to be used in cold mix.
Oh, okay. Have the fibers been used in cold mix? No, well, other than in the laboratory side where we've tried it, yes. Can they be put in there? Will it actually help it? Yes. I mean, cold mix is no different than dealing with hot mix. It's just an emulsion. So the fibers are going to have the same benefit through the crack reduction. In that case, Surface-Tech has a product that's more suitable for that's more, instead of bound with wax, it's bound with a water molecule. So Surface-Tech has categories for all these things that they can help achieve, whether it's in cold mix or in a hot mix product. Naturally, you would not use the wax bound product in a cold mix because it would not be able to release. Looks
There's
like
one last question. Shout out to Brian Collins. That's really good note there,
Oh,
Brian.
yes.
Thank you for that.
Yeah, the cost savings. Oh yeah, there you go. You're talking about the cost savings versus the fabric. And I've used you know, I work on a lot of airports here in Kentucky, and I'm on a special consortium where we put these in, and we have the choice of using fabrics, and fabrics have worked. You know, fabrics at the end of the day are made to hold the asphalt or bitumen, and they waterproof. They really don't do much for you at all for crack resistance. Geogrids are different, but the geogrids to install those get very cumbersome to install. They're great for what they originally intended, and that is with base improvement when you're dealing with soils and aggregate. I don't like to use grids in the pavement. I think it complicates things, especially if we have answers to it like what you're seeing today. So yeah, thank you, Brian, for that one. New Zealand, okay, Daniel, you have a question. You use 25% epoxy modified binder to improve durability. Are there any studies to evaluate the optimum fiber dosage? Oh, good one there. There's a study that our friends up at University of Alberta did, and they began to look at the dosage, and they actually put up to a 10x dosage in there to look at the benefit. They actually did a cost benefit analysis, and I guess it just depends on so the answer to what you're asking is it really depends on what you're trying to achieve. You know, the minimum of the single dose gets you what you want. If I had a choice, I would probably put a double dose in about everything I could get my hands on. I know it's a great number. It makes sense in what I'm doing on the airport project. You know, I'll just, as a rough number, we saw, while some people were claiming, hey, you may see a certain percent increase on the cost of the mixture, on the overall, and people forget this, on the overall scope of the project. When you look at going in, restriping, you're looking at the shoulders, you're looking at the lights, you're looking at bringing the runway back up, or you're looking at a roadway, you look at the traffic delay. Fiber, when you look at large scale projects, you're looking at a fraction of a percent on the overall cost of a project versus just the hot mix price that we typically would look at. So good question. I like a double dose. That's me. And but I guess it depends on your return to traffic and how long you can leave the traffic with your user delays. Climate, okay, Peter, you have a question. The climate changing relating to extended hot days with aged asphalt. Oh, good question. The aramid fiber that we can tell does not age that we can tell through through an oven. I mean, again, this is the same type of product that you're using in bulletproof vest. I'm sure on the surface that leaving it out for some time, you know, has any, as far as 15 years, 20 years, something has got to eventually break down. I have no data on that one way or the other. That's a great question. All I know is the projects I've been tracking, and again, one up to at least 8 years now, continues to show 80 to 100% improvement in transverse cracking. So that is the data that I have that I can share with you. Laboratory simulation, we cannot find where it the fiber ages at all. Return to, okay, very good. This is where I'd like to use the product and return to service environments, airfield construction. Well, Brian, I read your mind on that one. So yeah, I would love to talk more on airports. And Steve and Pat know I've been up to my eyeballs with airports lately in Kentucky. So very glad to share that type of information with you. Steve, Pat, George, anything else you would like me to address while I'm on? Oh, one more question.
There from Peter, you can do your
yeah.
lab. Yeah.
Oh, Peter, you asked that one a long time ago. Sorry, we missed that. And one of my favorite topics. Can the camera be turned on, guys?
Absolutely.
I'll try. Let me try to see what happened here. If it works, great. If not, it's not a problem. So yes, Peter, it works really well. And what we've done in the inner layers, I've used it with and I've used it without the polymer. I like using it with a light polymer loading, but it can be used without the polymer. In that case, I'm using a double dose in a 4.75 millimeter mixture, high asphalt content. So looking at about 8.5% asphalt minimum by weight of the mixture.
Hey,
and
Phil.
in that, yes.
Hey, Phil, hold on a
Yes.
second. George, if you scroll to the a couple of slides until you hit the Army layer slide, that way Phil can continue to, we have some pictures of just what that question is. There we go.
There
Phil.
you go. That's my little demo I like to do on camera, folks. And so by putting the fiber in there, there's double dose of fiber in the mixture. You'll never see it with the naked eye. You tear the mixture apart and put a spatula to it, and you would see it in there. But that type of mixture, naturally, it's a softer asphalt, but even with that, the mixture would typically break if you were to do that to it. By putting the fiber in there, the fiber kicks in, and we just got off talking to some folks just an hour ago, talking about a high strain environment in this very sense. And the inner layer is something I've worked very closely with now since 1998. And I was actually on an airport project when the idea came, and I contacted Steve. I said, Steve, I want to put this on a project. Steve said, sure, Phil, we can support you on this. We put it in there, and voila, it worked. We began the lab testing to vet it. And sure enough, it worked just like the higher end polymers I'd been using, and even more so to add, again, 3-dimensional reinforcement. So that inner layer is meant, that's actually a waterproofing inner layer, and it's made to greatly reduce reflective cracking, better than anything that I've ever used in my life. And that's based on about 18 projects to 20 projects I used to track across the U.S.
So George, I think we've got all questions pretty much answered, and except for this one here, apart from Hamburg ideal, have you conducted any mechanical testing of bezic, fatigue, and rubber running behavior?
Yes.
Phil, you want to answer that?
Yes, and yes. Mofrey, good to hear from you. Cal Berkeley has done fatigue testing. You've had cyclic testing done through NCAT and others. Hamburg and Ideal CT are just the common ones that roll off our tongue where it's done every day. We've had University of New Hampshire, University of Missouri, University of Alberta. You've got Johnny Habush over at VTRC doing testing on everything from, and I've done at Asphalt Institute, everything from indirect strength and creep testing to pretty much every battery of test out there, including fatigue testing. The only one that we're sort of kidding today that nobody's run is TRST, which is sort of an old school test, but still another good test today. And in that, again, you're improving every parameter. The only one that it just will not light up beautifully in is typically just a dynamic modulus. And why is that? Well, sometimes you'll get lucky, but overall, it's running compression. And if you're taking a fiber and squeezing it versus pulling it apart, you can't get the benefit out of it. So if you try to run dynamic modulus on it, you may get lucky, but probably not. Oh, flow number. I didn't mention flow number. And yes, you do get a great improvement in flow number testing.
Hey, George, slide 32 identifies all those tests that Phil just talked about.
Pat, I'm glad you got these memorized. You are a book, my friend.
Or I have the book.
Or you have the book. You got the playbook. Yeah.
There we go.
So as Phil talked about, we have tested the daylights out of our mixtures with our product in it. And then the next slide, he said, well, who tested it besides Phil? Next slide will show you that. And that's not all of them. That's all we could fit on this slide.
Yes.
I mean, I know we're missing some from this list, but
Yeah.
we have a lot of folks that have been working with us over the last decade to make sure that what we're doing is real.
Two more questions up there, actually two more questions.
Okay. Oh, back to the wrap. Yes. Using a higher percentage of wrap, any formula for using fiber, single versus 60% wrap, double dose. No formula as much as what we use the balanced mix design approach. So we allow things such as the Hamburg Wheel Tracker, Ideal CT, or like what it was being referred to earlier, if you have fatigue testing or things that you could use to help guide that. Again, fiber alone cannot fix a mixture when you get up north of or higher than 30%. You're going to have to do something to soften the binder, although the fiber will make it better every time. As Aramid doesn't need binder increase, has there been SMA with reduced binder using the same CT? I have not seen anybody reduce binder in the lab. Have contractors ever reduced binder when we go to the field? All the time. But do you ever see it in the lab where you intentionally reduce it to try to come up with the same CT? I have not. But could you theoretically take asphalt out of a mixture because of that? Absolutely, you could. So that's a really, really good point. Matter of fact, the local agency, the DOT that I'm with, that I was talking to, that I used to be with years ago and talking to, one of their fears is that contractor, because it works so good in Ideal CT, the fear is that they would remove asphalt out of the mixture because they're putting fiber in. So good point. And Mofri is asking, currently develop a new test to provide second layer assurance of running. Oh, that's great. Yeah. Thank you for sharing that. I really appreciate that.
So George, I think we are coming up on 10 minutes after our allotted time. You'll have a copy of the deck. You can, parse that around to whomever wants a copy of it. It's good information to share. The questions were outstanding. Good to see a lot of people's friendly faces and names. Love to connect back with them and keep things going with regard to the journey in your territory. Do you have anything else that you'd like to share, or are we good at this point?
Yes, great, Steve. If people are happy to carry on, we could should we skip through a couple of those case studies we had up there? And if people have got better things to do, they can log off. But we've got a recording of this, so we can circulate that around afterwards.
George, one of the things that we talked about yesterday was the PMB. You think we've touched on how we take care of PMD well enough, or do we want to do that as we're looking at the case studies?
Yeah, I think we touched on it earlier, but it'd be good to reiterate that it's not it can be used as a replacement for PMB, but it in fact it works very well with PMB.
Exactly, and that's why we had just a handful. We've got a bunch of solutions that we typically talk about, but we kept it to a minimum. We have done polymer modified binder replacement with neat binders in active projects. We have one in Pennsylvania right now, where we took a double dose of fiber with a neat binder and actually kicked our wrap content from 20 to 30%. And that was able for us to eliminate the heavy polymer binder, the standard polymer binder. I guess that's relative. The other thing that we've done a lot of work with, as Phil has talked about, was enhance the lower or mid-level polymer binder loads with a single dose of our fiber. And we've done that very, very successfully. And we have that on a slide coming up for those who want to take a look at it. And that's what we talked about early on in the conversation. But to start off, here is one of the case studies. You know, obviously we talked about we're on the NCAT track. We're also on the MinRoads track, and we're waiting for the results. But everything that we've seen thus far has been fantastic, and what we've been able to accomplish on, basically we are an additive of choice now for NCAT. We were recently asked to do a side project for NCAT just a few weeks ago in Eastern Alabama, and we did that for them very successfully just 3 or 4 weeks ago. So that's how far our products come along from us wanting to be on the track to not only being on there, but being requested. Next slide. This is some testing that we had done for specifically the reason of not having to use the high polymer loaded binders. Florida DOT requested Texas A&M to do a study to help them find not only different alternatives for high polymer loads, but also how to test for them. And so this is just a snapshot of one of numerous pages in this report. But when you take the polymerized mix, one that has 3% SBS, into the mixture, into the neat binder, and then we just add 1 dose of our ACE XP, you can see the huge impact on crack resistance. This is a CT index test, and we go from 123 to 172, outperforming anything that they tried, in their repertoire. And we know that a 3% SBS binder places so much easier than a 6 or 7%. And that's what they're trying to compare against in this report. Next. This is in Indiana, placed in 2018, which is an arterial roadway, 2-inch overlay on top of old concrete Portland cement pavement. So you can see the control section. This has a polymer modified binder, again, a 76 minus 22, I believe, which is right around a 3% poly load. And then our mixture, basically same mixture with 1 dose of fiber. In 10 months, you're already starting to see reflective cracking come through. And on our side, nothing. Next slide. This is what I'm talking about the enhancement into a polymer mix. Again, this is about a year later, starting to see the cracking reflect through even more. Next slide. This is cracks measured by Mr. Blankenship. In 22, 4 years in, you can see the cracks coming across. They hit our section and stop abruptly, and they don't pass through, which is a rarity. So what happened. This is the lab testing right there from the field samples that George is showing. And you can see the field samples themselves showed an increase in crack resistance anywhere from 44 to 111%. That's in a laboratory off of plant mix field samples during production. Next slide. This is the wow moment. This is the crack number of crack count. And Phil, this is your slide. You want to talk to it?
Yeah, yeah, glad to do that. This is just where we went out, and this is not a PCI value. I mean, if I went out and looked at the actual PCI on this, you've got about I think it's about 8 points different on the pavement condition index. Some people call it a pavement PCR, pavement rating index, which looks at all the different components. But this is just looking at transverse cracking, and transverse cracking, of course, is that early indicator of long-term performance. This roadway is an airport access road just outside of Indianapolis Airport, not too far from Indianapolis 500 that you may have heard about, where they do a little racing out there. And in this one, you have the control, of course, is the standard treatment with a 7622, and the bottom is a 6422 with the ACE XP single dose of fiber. And when this was done, the contractor simply added the Aramid to see what the cracking difference would be. What's resulted, the result of this, just to give you the quick end of the story, is this: today the city went back and, of course, naturally specifying more, not just from a bar graph. You walk out and you see it, and it's just astounding. But when we went out to look at it every year, you're looking at, what's the cracking doing, what's the cracking doing, and the cracking continues to grow as you see from year to year. Going out usually in about April or May to look at it after you get through the winter time. But when you look at that little blue bar at the bottom, you barely see any cracking at all happening. And what I did, just as an eye opener, I sort of threw a trend line on there, and I don't have an R square or anything, but it gives you an idea very quickly on the crack rate when you're going from one year to another. But if you're looking at you're growing, in this case, we're working off of feet. So sorry about the English units, but you're growing at 300 feet in 5 years as compared to about 25 feet after about the same length of time. So what an outstanding number when you're looking at 6 to 8 times, depending on which bar you're looking at, 6 to 8 times the difference in cracking after that 5 years, 5-6 winters of performance.
Thanks, Phil. We just got another question from Robert. Can you see it on there about the crumb rubber?
Oh, any compare? I don't have comparisons with crumb rubber. They're actually doing that right now, Robert, at NCAT on the test track. They have an additive group study where they're looking at 2 different plastics. They're looking at rubber, polymer, and aramid fiber. Aramid fiber was actually one of the ones, as the others were, as being voted in, and Surface-Tech was actually voted in by the local agencies to be put on that track. With that, they're comparing it to the rubber section. All we know right now is the rubber is the only section that has an initial crack in it. So structurally, rubber is going to flex, and that is not good when you have a weak base. So I'm thinking that's why that initial crack's coming in. If you're looking at it as far as a wearing surface, as far as the top, like in the top, let's say the top 25 millimeters, top 50 millimeters, I don't see how rubber could compete with the aramid fiber. The way that you could use it in a comparison would be if you let it down with a lighter oil, lighter asphalt. You put the rubber in and try to use it as a modifier as you would SBS, then you could come up with something comparable. But rubber is just a different beast because the way it's modifying versus reinforcing. I guess I will make a call out to rubber in that if you use rubber and open graded mixtures, it does a good job at noise dampening. Steve and Pat, I would love to make a claim that Aramid fiber is noise dampening, but you're going to have to pay me to do that work.
Great, thanks. Phil, do you want to just quickly carry on with the lab side of things?
Yeah.
Bill, I will say this,
Yes.
that if you reduce cracking and rutting, your ride will be smoother,
100%.
and
That's
therefore
right.
you will not hear the rattling inside of your car that you get when you run over potholes and distresses that you currently do.
Hey,
How about that?
I'm all about that, Steve, and that's exactly right. Good analogy.
So Phil,
Okay.
there's your lab
Yes.
SOP.
Yes. So, and when you're using this, you can't just, we've been, of course, working there with the university on this very thing. You can't just go and add aramid fiber and just sprinkle it in and make it work. Again, it's not cellulose fiber. It does have to be properly dispersed in your mixture. The plant side is in the field is easy. In the laboratory, you have to do a little bit more pain to actually go in, and it's not bad. It's just different where you layer it in, and we're using a bucket mixer and a paddle. You can't use a wire whip or it will gather on the wire whip. And you have to use a precision scale because most scales are only good to 1 decimal place. Notice here we're using 3, and that way we're getting it layered in, as you saw there in the. Yeah, you can go ahead in the next picture. We're going to divide the fiber up really well. We would do that ahead of time, and then as it's delivered to you to put in the mixture, we'll put it in and we'll layer it in that aggregate in about 3 different layers. And then once we get it all layered in, then we'll make the cone and we'll put the pour the bitumen in, and then we'll go through the normal mixing process. And through that, we're able to get very good lab dispersion, and then it's ready for testing.
Yeah, there's a good link to there's a video link there which will get out to everyone that shows that in action really well. So
yeah,
Thanks,
while I summarize that in 30 seconds, Surface-Tech has put a lot, and I mean a lot, of work and money into this to refine the laboratory mixing. They knew it was important, and they put the money into this to make sure that we have a good process, and even more so lately, the videos and the documentation that goes along with it. Surface-Tech will take care of you all the way through on that to make sure that you have success.
Great. Well, I think that's with a few slides we skipped through there, but we'll make sure we get this out to everyone. And we've got through all our Q&As, unless anyone else has got any they want to add in. But that was really good, and thanks very much, Steve and Phil and Pat and the team.